Come back. So this is the last example I'll be showing you, tree, in this particular lesson, lecture 14. So tree is over here. Have a look at it. This is a little more complicated than the previous example. So let me first draw it and you will see what it does, right? You want to draw it, so I have a small piece here, code to run it. Let's see. First of all, nothing is drawn. I've just created some objects. One is a stem, the other is a branches. The object itself is called branches. Okay. If you go back to stem class, it has a draw method. If you go to branches class, that also has a draw method. Mind you, this is rather unusual. Our class name is usually singular, but you will see why I had to use plural. All right. So anyhow, I have constructed these objects. I would like to draw them. Okay. So one is the stem object. What was my stem? Oh, it was small case stem, small case branches. Stem dot draw. Aha, it drew something. Branches dot draw. So that's my tree. Okay, this is what I wish to draw. If you look at this, the stem part was right here. Yes, and branches started from over here. Now notice the stem is not recurring anymore. It's the branches which recur. This is V, and it's the same V here, same V here, same V here. So just these two, left branch and right branch, start repeating themselves. Okay? But notice here, this is right angle, straight up is right angle, and I have a certain slope to the right and a certain slope to the left. Now, for this particular pair of branches, I'm no longer at a right angle. The central reference is no longer right angle. So I have to take this and add a little more to give this reference angle. I have to take this and subtract a little angle to be a reference angle here. I hope you understand what I'm saying. So the axis here at this point is vertical, that is at 90 degree. Whereas the axis here is no longer 90 degree. Axis changes. Axis here is less than 90 degree. And so on. And you keep drawing however many times. So let's understand the code. Let's at least understand what we called. We started with the root. We built a canvas, packed the canvas, stem. In that particular canvas, at 250, 500, 125. Aha, what are these things? Let's figure out the stem. The stem. Rx, Ry, height, girth. What is Rx and Ry? Aha, those are the coordinates of the root. Okay, so the root is here. And that is why you were at x coordinate right in the middle and y coordinate was the maximum. So you are at the bottom. So that is 250 and 500, that represents this particular point. 125 represents girth. So Oh, sorry. 125 represents height. Where did it go? Yeah. 125 represents height. So I have 125 pixels high. Girth means thickness of a branch. It's called girth. Thickness of a stem, it's called girth. Girth by default setting is 10. You could change the girth. All right. So let's have, instead of 10, let's have 20. Okay. I would have to run it again. Stem.draw. So it's a thicker girth now. All right. So that's fine. So I hope that was clear. Once you have this information, height of my object is the height I give it. Girth of my object is the girth I give it. Canvas for my object is a canvas I'm going to draw in. Rx and Ry, those are the coordinates of the root. Rx and Ry minus height. Why minus? Because this, in graphics, lower you go, greater the y coordinate. So I have to reduce the y coordinate. How much should I reduce? I reduce it by the height. So that is my second point. I'm simply, so this is information about the stem. How do I draw the stem? In the canvas, create a line segment from the base, that is the root coordinates, to the top coordinates of the certain width. Width tells me how thick I can draw my line object. So that's how I got the stem part. Now branches. So let me draw the branches. Okay. So there you go. That's my branches. It doesn't look right. Maybe something changed. So girth was 10, the base case. Branches. Okay. Maybe that. Let's see what branches class takes. It takes a canvas. What is this 250? What is this 375? Let me understand that. 250, I suppose, is the x coordinate because you have to start in the center. What is this 375? 375 because 500 minus height. Okay, that's the height. 500 depth minus height, 375. So these two represent the x and y coordinates of this point. 0.7 times 125. What is that? Let's go to branches. Base x coordinate, base y coordinate, length. So I don't want the same length branch here. So I'm taking 70% of my original length to be the length of my branches. Okay, that's what this does. What next? Girth. I'm reducing my girth. I'm reducing it by 7% of that was 10. So let me change it. So this was the girth, 20 was the girth. So 7% of 20 is 14. Over 14. What is that? 10. Number of layers. How many layers? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's how many. So let's increase that also. Right? We can play with these. So instead of 10 layers, let me take 15 layers. All right. And recursion, by the way, starts slowing down rapidly. Okay. It's very important you notice that. It slows down very rapidly. Okay. So stem dot draw, you drew, branches dot draw, it slowed down. Look at that. Because I had 15 layers, it became very lush. All right. So branches are the interesting part. How do we, so you saw what all these things meant. Angle and reference angle. What is angle and what is the reference angle? Angle is the amount of angle it takes away. Okay, it must say maybe here. Right. Angle between sibling branches. So this angle is the same as this angle, is the same as this angle, is the same as this angle. That is my angle. What is the reference angle? Reference angle at this point is 90 degrees or pi over 2. At this point, it is less than 90 degrees. At this point, it is greater than 90 degrees. Okay? So that's what reference angle is. In our example, we gave reference angle to be pi over 2. So we started at pi over 2. And then it changes as the recursion proceeds. The angle between two branches, we gave it pi over 3, which is 60 degrees. You could experiment with more or less. And then with all that information, you have your instance variables, left branch, reference angle, plus this angle, half of it. Why half of it? Because if that's the reference angle, one half is here, the other half is here. So you're adding that angle for the left branch. For the right branch, you're subtracting that angle. Okay? And now you're starting with the coordinate. You're just adding, you want to find this coordinate and that coordinate. So for the left branch, this coordinate. X coordinate is cosine of your angle. Assuming the center is origin, but now the center is here. So x coordinate of this will be x coordinate of this plus cosine. Likewise, y coordinate will be y coordinate of this point plus sine. Okay. Now you don't want just sine, you want length also. Otherwise, all the length will be 1. And you don't want 1 pixel or length for branch, and that's why you have self dot length here. Right branch is the same approach, nothing new. The only difference is angle has changed. Okay, so if the number of layers is 1, then no more left drawing, no more right drawing, and that's why right rest, left rest, no more. So those are non objects. If number of layers is more than 1, then left rest are branches some more. So notice branches class will come up with its own. So over here will come up with its own left and right branch, left and right branch. But you are going to reduce the length of each new branch 70%. You are going to reduce the thickness of each branch in comparison to its parent branch by 70%. You're reducing the number of layers, you're maintaining the angle the same, and your left branch angle will change. You see, I don't want everybody to be growing around this axis. The axis changes. Left branch angle, reference angle changes. Right branch angle, reference angle changed. Okay, and that's all. The rest is same. Play with this. If you don't like my tree, draw your own tree, learn recursion. Okay, so this completes lesson lecture 14. I will be sending you a homework problem, and here it is for you to see. You want to the question is given at the end of this file. All right. Until then, bye.